lot of background noise. Well, are there any questions from our last class meeting on Tuesday? No questions? It's all good? Okay. Well, I know that not everybody have logged into Moodle. Well, let me show you how I know that. Because I can sort by last access. And so I can tell a few people have not logged in. And some people are new ads, so I manually added some of these people, so I can understand, why they may not have a chance to log in yet. Yes.
Is that the website that you went to, or do you go to Moodle like that?
No, you go to someprofs.org, not Moodle. Yep. The Moodle is the name of the software, and SomeProfs is is my own website. So my website uses Moodle as a product to conduct classes. It's kind of like D2L is the product, and the Los Rios district is using D2L as a product to offer the service. Okay. When you get the message from email, it actually gives you the URL to the website. So you might want to use that to go to the website. That's all right. Any other questions? It's good to have this kind of stuff, cleared up, early, like in the first week or so before we have more homework assignments. All right. The second thing is the homework assignment. This is your homework assignment. The first homework assignment is due on Tuesday next week. Okay, so you do have a few more days to do it. Do you guys have any questions?
Yeah.
May I answer a question? Go ahead.
I couldn't find the reading assignments. When I sat in, it's pretty much look different than whatever you have right there.
Are you sure you went to someprof.org and not Moodle.org?
Yeah, I logged in too, and the email says that this is your initial password or whatever.
Right.
And then I sent in, and then the pictures look different than.
Did you click on the class? In other words, were you
Yeah,
looking?
I did, but
Okay, this is the initial page when you first log in.
Yeah.
And you have to look at My Courses, and you have to click cisp300.
Yeah, when I click it, it's like this really small screen, like cut off in the middle.
Right up in the middle.
Yeah.
Did you click on one of these buttons?
No.
No? Because if you click on one, then it will only show that topic and everything else will be hidden. So
The user agreement.
the user agreement, you have to read the whole thing and then click yes to it. Did Moodle ask you about the agreement?
Yeah.
Okay.
That was like in the middle though.
In the
Like,
middle.
They cut off like just a little thing in the middle. That was really looking
Okay, I can log in as you later and
Okay.
check what's happening.
Okay.
Okay. Any other questions about the homework assignment? No? Oh, that reminds me to turn off my phone, or at least turn it into silent mode. There we go. Well, thanks for the reminder. So that my phone is not the first one that beeps in the class. Okay, that would be embarrassing. Any other questions? So you could get to the website. It's just it doesn't look like what I showed
Yeah.
here. Okay. Any other issues? I mean, no. Okay.
What browser does she use?
I'm using Google Chrome, but it will work in. Oh, you mean which browser were you using? That's Internet Explorer.
Yeah.
I would use either Firefox or Google Chrome. Those two definitely work really well with Moodle. Later on in the class, you will also see Internet Explorer has issues. That's why in the main page, let me go back to the main page here. There's a big article here. yellow background and red text saying use Firefox if you encounter problems with Moodle authentication in Internet Explorer. Particularly in the lab, I don't know why or how it happens, but in the lab, if you try to log in using Internet Explorer, it would actually fail. It does not log you in, which is really strange, because the problem has to do with IE could not set cookies when you go to Moodle. But it doesn't give you any warning either. It doesn't explain why it does not let you set cookies when you go to Moodle. So I would just use Firefox, or some of one of the other alternative browsers. Opera would work, Safari would work, WebKit on your cell phone would work. Everything except for Internet Explorer. And most people think that I intentionally make it so, and I can tell you I did not. Okay, this is not something that I intentionally do. All right. Any other questions before we continue? Yes?
The role, I wasn't in the Moodle program when you took role.
Yeah, that's fine. It would just show that you are not, it won't show an entry, so you're not absent either. It's just that, at that time you were not in the class. So that's fine, because I only count absences, confirmed absences, before I say, okay, this person has, missed 2 or 3 classes or something like that. So that's also a good reminder. So today, finally, I got the printer to work. So I'm going to use this to take roll. Just sign your name, next to your name. You can initial. You can sign your name. And if you are not in the class yet, but you're on the wait list, you will also find your name on the wait list. And I want to keep track of who on the wait list has been coming to the class consistently. If you're not on the wait list, you're not in the class, there's still a little bit of space left. And so what you can do is to write down your name somewhere after the wait list. Okay, so that way I can also track people who are not even on the wait list but have been coming to the class consistently. Okay, so I'm going to pass the row sheet from here. So make sure you get a chance to sign your name to confirm that you're in the class. All right, last time we were talking about developers, and I was showing the video clip with Steve Ballmer, CEO of Microsoft, chanting developer, developer, developer until he ran out of breath. So I did this every semester, with this class, and there was one semester, after the class, one one student came up to me and said, "Tack, do you know what is my last name?" I said, "No, not particularly." He said, "It's Ballmer." So he claimed to be a nephew of Steve Ballmer, so they are related, okay, relatives. And he, but I didn't show anything that is inappropriate, right? I mean, it's something that he actually did, is not made up. At the end of the semester, he was asking me some questions that just surprised me, okay? It's not, Tech, why are you still working here? I thought you were fired. It's nothing like that. He asked me how to install Linux on a PSP. Yeah, it's just kind of strange. But I think I have converted someone to use a Linux instead of Windows with the last name of Ballmer. In the middle of the semester, this is when Windows 7 first came out, and he brought in, like a shrink-wrapped version of Windows 7, and he was just waving it in the class. He was so proud that he could get his hands on, one of the first, released, packages of Windows 7. At the end of the class, he was trying to use Linux on a PSP. Anyway. So, developers are very important, and as are computer scientists. These people are basically responsible for the software components of a computer. And remember what we said about the hardware? The hardware has progressed really tremendously over the past 50 years. But when you look at software, not a whole lot have changed. Okay? The father, quote-unquote father of computer science is, his name is Alan Turing. And he came up with most of the theory behind, the software of a computer. And guess what? There has been no change in those theories over the past 50 years. Okay? Now, what has changed is how difficult is it to write programs for computers. That has changed, but not even at the pace of hardware. Okay, let me show you, a picture of the Altair computer. Altair. I might have misspelled it. Oh, I got it right. All right, so this is an Altair computer, and I'm popping up a high-resolution picture so that you can see, what it looks like. It's one of the first personal computers. It's actually affordable, so that individuals can buy the kit. They have to put everything together, and this is before the IBM PC. This is before the Apple II computers, and it's the first personal computer. All right. So here's my question: how do you write programs, using something like this? I don't want anyone to say, oh, it's Bluetooth. I don't see any keyboards here because it has Bluetooth. Yep.
Everything runs off of Logitech disk, just switch them out every time.
Exactly. All the switches in the front here, see all these toggle switches. So you program this thing one, I guess, byte at a time, or maybe even a nibble at a time. So you have to specify which address in memory using these toggles, and then you have to specify the content at that location. At the very end here, there's one toggle that says, write to memory. Okay, click, click. And then what do? You advance to the next location. You specify the instruction that goes into that location, and then you say, okay, write to memory. And you do it this way until you have a program programmed into the memory of this system. Okay. Now, what type of instructions are we talking about? Nothing like what we'll be talking about in this class. Okay, those instructions are basically all zeros and ones. They're called binary code or machine code. Okay, they're called machine code, and you have to remember which machine code will add two numbers. You have to remember which machine code will subtract two numbers. You have to remember which machine code will compare two numbers. Okay, and then you have to remember the locations of those instructions too. So that means writing programs is quite tedious. Okay, let's just say it is quite tedious using a computer like this. And what do you do to write programs these days? You have Visual Basic. Okay, you have. Sorry.
So you have like the and or like the and statement. It's all loops now, but it's still running binary in the background.
They're still running in binary in the background, but in the in front end, you can use a language that is more natural to human beings. It's not zeros and ones anymore. So that has changed over time. But in terms of the operation of a computer from the software perspective, that has not changed. Okay, the basic instructions, what this computer is capable of, is still pretty much the same thing as what your i7 can do these days. It's just that the i7 can do it much faster than this computer. But in terms of theory, they're pretty much the same thing. Adding, subtracting, comparing, storing, and then retrieving. They are still pretty much the same thing. All right? So there are there are different roles, different types of people when we are talking about software development. The first ones, they're called systems analysts. I'm not going to read this part here; it's kind of boring. So instead of reading this, I'll just ask you some questions and using an analogy instead. So let's just say that someone gives you a piece of land and it is really nice. It's very scenic. Along Highway 1, at the coast. Okay, but it's just the land. It oversees the ocean. You have access to the cliff, so your property is is really nice. So let's say you're sick and tired of camping, on your property, because, well, guess what? It's kind of windy and kind of cold, so it's not really the best place to camp all year round. Maybe 1 or 2 days in a year would be good. So you want to build a house. Okay, you want to build a house on your property. What would be the first thing that you need to do to build a house at the property? Let's just say that money is no problem. Okay, go ahead.
Get a general contractor.
You need to do something before that. Go ahead.
You need to get water.
You need to get water?
Yeah, because the state will not allow you to put one stick of wood on the property unless you have fire protection.
Okay, well, but even before that, okay, Yep.
You need the architect, right?
You need an architect. Okay, an architect. What is an architect? What does an architect do?
Designs like the building itself.
Sorry.
He designs the building itself or whatever.
Well, the architect doesn't build something. He designs. Okay, yes. An architect would actually work with you, who is the client, and what type of question do you think the architect will ask?
How much will you pay me?
But I said money is not a problem, so how much you will pay me is not an issue. Yep.
What do you want in your house? What are you supposed to, what needs or what are you?
Exactly. What are the requirements? What are your preferences? Okay. So which side of the house do you want to have the garage facing? Okay. How many stories? Okay. Do you want a single story house? Do you want a multi-story house? Do you want to have a panoramic view of the ocean? Okay, which would be nice, if you have access to the cliff. Do you want an overhang, that extends out of the cliff, with fiberglass or some other transparent material as the floor, so you can actually walk out there and you can look under yourself and you can see the waves, splashing into the rocks. Okay. I mean, those are valid questions, right? So the architect will ask you these questions, and then you as the client will tell him tell him or her your preferences. Okay. Yes, I do want to have a panoramic view of the ocean. I want it to be on the second floor. Okay. The first floor, I will do it. I will use it for something else. I want to have gardens, a multi-level garden next to the house, and so on and so forth and so on and so forth. Okay, you can even tell your client and say, I want to make it extend out of the cliff. Okay, you can ask for anything you want, and the architect will draw a picture of the house, of your dream house. Okay, now how do we call that picture of the dream house? The blueprint. Very good. Okay, the blueprint is the beginning of the entire project. Okay. Okay, so now the architect is done. The architect shows you the blueprint. You approve the blueprint. Okay, this is exactly what I want. And these days they can give you a 3D rendering of the building before it is built. Okay, they can overlay that on top of actual pictures, so that you can have a pretty good idea of what it looks like from the outside and what it looks like from the inside out, and so on and so forth. So let's just say that you're really happy about the design and you're ready to go. So next, what do you do?
A building permit.
A building permit. Okay, but before you get a building permit, you need somebody else. Yep. And before you get a contractor, you still need somebody else. Yes.
You need an engineer to make sure that the concept can become reality.
Exactly. You need an engineer, a civil engineer, okay, because there are all kinds of engineers, but in this case it's a civil engineer. The civil engineer will look at the blueprint, and the civil engineer will do all sorts of calculations, okay, and the engineer will say, well, your house is really close to the cliff. Is the soil type or is the strength of the rock of the cliff strong enough to support your house reliably? You want an overhang that's extending out of the cliff. Okay, what type of material can be used? Is it possible? Is it safe? So the engineer will come back and say, okay, this can be done, but I need to make some changes. Okay, I need some more beams, which will make your house not as pretty, but it is safer that way, and so on and so forth. So the engineer will look at the blueprint and make sure that make sure it's feasible. It can actually be built that way. Only after that you can go try to get a permit and get all the paperwork done before the project begins. And then what do? You have the architect helping you to design the house. You approve of that. You have the engineer to double check everything, make sure the house can be built and it is safe to do that. And let's just say that you have no problems from the local government or the state government to have this built. So what do you do next? Contractor. Okay, very good. Is that your answer too?
I was going to say, prepare the environment for the house being built, whether it's kind of a contractor's job.
Yep, it's a contractor's job. Okay, but now I have a question. Why can't you just ask the architect and the engineer and just tell them, I want you guys to build a house for me. because ultimately you know what the house should look like, and you know what material we are supposed to use. You know how to make the house safe, and so on and so forth. I can trust you too. So why don't you two go to Home Depot, buy your tools, and come back here and build a house for me? It's not their job. Now, but since I said money is not a problem, you can just tell those people, tell the architect and the engineer and say, I can pay you as much as you want, but I want you to build a house personally. I don't want you to subcontract to somebody else.
Oh, why can't you say that?
Yeah. Why? The question is, why is that not a good idea?
That don't know how to do it.
They don't know how to do it. Quality, because they are not. This is not the sort of work that they are used to, right? I mean, if you are thinking about an architect, an architect is mostly working with paper, and these days mostly with a computer. And an engineer is about the same. Okay, the engineer actually has to go out to the field, collect soil samples, drill down, test the strength of rocks and whatnot. But that person is not used to actually building a house. Okay, if you give an architect a power drill, that person can do more damage than good, potentially. Okay, I'm not saying all architects are like that, but you cannot make the assumption that an architect naturally knows how to build a house, even though he knows the design inside and out. Okay, and it's the same thing with software. If you look at a program, a piece of software, it's like building a house. You are the client. Okay, you are the one who want to have something built. I want to have a program developed. I want to have a program implemented or done in order to accomplish a particular thing. I can be Wells Fargo Bank. Okay, I can be Wells Fargo Bank, and I say I want an information system that can help me streamline everything. I want it to be used internally, so the clerks, the bankers and whatnot can use this system to improve their work efficiency and accuracy. And I also want it to be external. I want people to be able to log into my online bank and do online banking. And by doing so, my clients will have better access to their financial information and do online payment and stuff like that. So you are the client, you're Wells Fargo. But before you can have the system built, you need to have the architect and the engineer to help you design the system and make sure that it can in fact be done. Now in software land, they're both called systems analysts. In other words, the job of an architect and the job of an engineer are combined and rolled into one, and we call those people systems analysts. Okay? And that's why we have systems analysts here. I'm not going to spend too much time to talk about systems analysts. Only to the extent that they still need to understand something about algorithms and software design, but not to the same degree as a developer or someone who actually writes the programs. So next we have the developers, and this is a more important slide. And just like I asked the question, why don't you ask the architect and the engineer to build your house? Actually go get the material, the tools, and whatnot to build a house. I can ask the same question. How come we don't ask or have the systems analysts to actually write the programs? Well, as it turns out, in this case, there are fairly good reasons why not everybody can be a developer. So we'll take a look at the major challenges in writing programs. Okay, what do you need to write programs? The first thing is you need to understand the syntax of programming languages. The syntax of a programming language is like the grammar of a programming language. Okay, it specifies, oh, you have to put parentheses around these things. You have to have commas to separate these things. You need to use open curly brace here and close curly brace here, and so on and so forth. That is the syntax of a programming language. Just like grammar with any natural language. But there's one major difference. Okay. Now I know I don't have perfect English grammar when I use it, when I speak it, or when I write it. But for the most part, I don't think you guys have major issues with understanding what I'm saying. If I say yesterday I picked up my daughter from school, instead of yesterday I picked up my daughter from school, the past tense thing, would that hinder your understanding of what I meant? It's not perfectly correct, but yet the meaning is okay, because yesterday already told you this is something that happened in the past. So even if I use the wrong tense for the verb, it's still okay. What about with computers?
That'd be bad.
You miss a semicolon, what happens? The computer does not understand what's going on. You use the square brackets instead of parentheses, what happens? It means something that is completely different. Okay? So that's why the syntax is a big deal, and some people just cannot handle the syntax of a programming language. Now, most programming languages do not resemble natural languages because natural languages are by its very nature ambiguous. Okay, I'm pretty sure you can find books, and all the jokes, in the book are about how to misinterpret a sentence. You put a comma into different places, and you can change the meaning of the sentence completely. Okay. But in programming languages, it has to be very precise. Okay, we cannot afford to misplace stuff. Okay, so that brings up the second point here, which is the syntax of most programming languages must be very exact. You cannot say, oh, sometimes I use a comma, sometimes I use a semicolon, and other times I use a dash. Okay, well, you just cannot. You don't have a choice in the matter. But that's okay. Most people, can handle, syntax just by exposure. Okay, you use it day in and day out, year after year, and sooner or later you will get used to the syntax of a programming language. I would not consider this to be a showstopper. The second one is a little bit more involved. Okay, programming logic. Okay, the systems analyst will work with high-level logic that can be represented by flowcharts and just descriptions. For instance, I can tell the banker. Okay, remember I'm Wells Fargo Bank. I can tell the systems analyst and I say, well, for security reasons, if someone fails to log in 3 times in a row, lock out the account. Okay, well that's fairly easy to understand, and I can use a flowchart to represent it pretty easily. It's just fairly easy to do it. But in terms of the implementation of that logic in an actual program, it really is not that simple anymore. First of all, how do you know which customer are you talking about? Second of all, how do you keep track that that person or that account has some failures to log in? Okay, authentication errors. And third, how do you keep track? This is the first time, this is the second time, and this is the third time. Now I can add something to the original logic that will just it's just a minor. I just have to add a clause to it. Okay, I can say lock out an account that has 3 consecutive login failure within 24 hours. Okay, well, that's really easy for me to express. But guess what? The programmer who's going to code it, that's major changes to the code, because now you also have to keep track of the time, and then you have to keep track of the time frame. When is the first one, when is the second one, when is the third one, and then you want to keep track. Okay, are those within 24 hours? Okay. So as a result, programming as an activity requires extended periods of highly focused attention to logic and details. Okay, I didn't write details here, but logic and details is what you need when you're writing programs. And that's really, it requires a lot of focus. Okay, there are certain things you don't need a whole lot of focus to do, like washing dishes. Is not something that you need a lot of focus. But programming is one of those things that you need a lot of focus. And this requirement to require a lot of focus conflicts with the other duties of a systems analyst. Because guess what? The systems analyst has a major job. Its main job is to interface with a client. So the client can just call up a systems analyst and say, oh, guess what? I forgot to tell you that I want the account locked out to be limited only to 24 hours. Okay? And that call can happen at any time. You will have scheduled meetings with clients also. Okay, 1 hour meeting here, and 1 hour meeting over there. So you don't really get control and say, okay, I want to have at least 4 hours of no interrupts so I can focus on coding. You don't have that option. And the last point is, some people cannot stay focused for several hours at a time. Okay, it's just, some people can do it and some people cannot do it. Some people can multitask and some people cannot multitask. So it's not really a strength or a weakness. It's just that, the same people who cannot focus for hours may be very good at multitasking. They can answer the phone, they can, keep track of, meetings, take notes on, for something, all happening at the same time. They may be able to do that. It's just that they cannot focus on one single task for hours. Okay? Are there any questions so far? So what I'm doing is I'm just describing what it takes for someone to become an effective developer or a programmer. The last part is is the most important part. I used to be a TA at UC Davis, and most students are very eager to start on a programming project. The moment they get the assignment, they're all really motivated and they want to go to the lab right away and start coding. Okay, but as soon as their program do not work the way they should, they get discouraged. They get frustrated. Okay, this program is not working. It's just not working. And as it gets close to the due date of a homework assignment, the frustration turns into panic. Okay, and I have seen this. Okay, I've seen this at UC Davis. Some students will start to make random changes to the program. Okay, it's just saying, maybe I'll just be lucky and this change will fix the program. And guess what? They usually make it worse. Think of fixing a car. Okay, think of fixing a car. You bring your car, your car simply won't start. You take it to your mechanic, right? And then you tell your mechanic, I want the car back in 3 days. The mechanic spent, the first 2 days trying to work it out and got really frustrated, broke a few wrenches and stuff like that. And then on the third day, the mechanic just decided, maybe I'll just, randomly disconnect some hose and reconnect stuff, maybe that will fix the problem, okay? I don't want to take that car back. Okay? It's the same thing with programming. Now, diagnosing faulty programs, programs that do not work, can take up much of the work hours of a developer. A lot of people, when they want to take on programming as a line of job, they think about all the glory of writing programs. Okay, I'm going to write the program that will do this and that. It's really going to be cool. But guess what? Most of the time, the first jobs that they get is what? Fixing old programs. They'll give you a program that somebody wrote 20 years ago, and that person no longer works for the company. Nobody knows anything about that program, and you are the person who is going to fix the problem. Okay? Well, why? Because this is a good filter. Anyone who gets frustrated by this kind of work is not cut out to be a good programmer. It's also good exposure, because if by doing this, the developer or the new hire would actually get the exposure to learn the program. Okay, because you have to get into the source code, you have to understand how it works, at least up to the point that it breaks, and it's just very good exposure. So it's a good training activity for new hires for companies that develop software. Now, debugging also requires long periods of focus, but in addition to that, in addition to focus, you also need a very analytical mind. Okay? In other words, when you're debugging a program, thinking out of the box may not be a very useful asset. What you need is an analytical mind. Okay? The program breaks here, but what can lead the program to get to this place to begin with? And so on. So you have to walk backwards, okay, from the point of failure, and you have to walk backwards, and then you try to figure out, how did I get here to begin with? Okay, and that requires a lot of analysis, a lot of logic. And the next one is a temperament that stays calm after repeated failures to locate the problems. Throwing your mouse across the room is not going to fix the problem. Okay. Now, I mentioned that because I have colleagues who used to do that. Yes. Not a software engineer, but a hardware engineer who basically just flew his mouse across the room And our HR department actually asked him to sign a letter and say that, I know this is wrong, I will not do this again. He almost threw a second mouse, that time. But that's the whole point. I mean, you cannot get frustrated. Getting frustrated with the computer is not going to help. Okay, it will only make things worse. I was also tasked once, with locating a bug in the firmware of one of the products that we released. The product is already released to the clients, so there were hundreds of clients using this product already. But when we changed the batch number of the chip that we were using, for some reason the software did not change, but there was a problem. The software does not work reliably anymore. Okay, the worst part is sometimes it works and sometimes it does not. Okay, so I was tasked, to find out what the problem is and fix it as soon as possible. Of course, the marketing people and the sales people are very anxious because they are the one who eventually have to talk to the clients. Okay, the clients will call up and say, okay, how is this bug? Have you guys located the bug and fixed it? And can we get on with our projects? Again, so I can understand they're under a lot of pressure. So the marketing manager decided to come to my cubicle every hour and check with me, is it done yet? And he will ask those questions in a meeting and so on and so forth. So finally, the sales manager just told the marketing manager said, just leave Tack alone. I mean, if you keep bugging him, it will only slow him down. Because what I need is just time. I just need time to work on it. Okay. And whenever the marketing manager asks me, when is it gonna be done, I can only give him the only answer I can give him, which is it will be done when it's done. I have no idea whether it will be the next hour, the next day, the next week, or the next month. I'm I'm doing my best. Okay, I'm analyzing the problem. I'm working on it. I'm not goofing off. But other than that, I cannot tell you how long it will take to fix that bug. Okay, so that's the kind of personality that you need in order to become an effective developer. Okay. So is anyone planning to drop the class because you want to change your major? Not yet. And in terms of the fun of writing programs, personally for me, debugging is the fun part. Okay, that's the part that that really, it's like putting a puzzle together, and it is very controlled. I mean, because it's software, so for the most part, things are very predictable. Many types of defects or bugs in programs are predictable, or I should say deterministic. In other words, you give it the same test data, it will behave exactly the same way, which makes it actually pretty easy to find out why it is doing it, because as long as it does the same thing repeatedly, you can always stop here, check, oh, okay, this is not where things are broken, move it back a little bit, do it again, and you can always repeat that process. There are bugs that are not quite like that. Okay, you can have a single bug, a single defect in software, and the symptoms can change dramatically. First of all, how often does it happen? Sometimes, with a bug, it can happen once a year, and then suddenly it switches to once a month, and then suddenly it switches to 3 times a day. Each time it happens, it can have a different symptom that is not related to other symptoms of exactly the same bug. Okay, and I'm used to debugging that type of program as well, with nothing other than an LED. It happens when you are developing embedded systems. Okay, when you're developing embedded systems, a lot of times you don't have the same tools as when you're developing a quote-unquote conventional program. So after a program is designed and implemented, you need someone to test it. In other words, after your house is built, somebody is going to go into the house and make sure that everything is done exactly the same way as the engineer and the architect designed. Who's going to do it? I know you are not going to do it, because you may, as a client, you may not have the expertise to test everything, the way it should be tested. So who is going to test it? Let me ask you a few questions. Would you ask the architect to double check and and say your building, the house is built exactly the way it should be. The electrical connections, the plumbing, and everything else are done correctly. Would the architect be qualified to do that? No. How about the engineer? How about the contractors? Let's just say that your contractors are very honest people. Okay, so they would not do something to trick you or to hide defects. Would you have your contractors to double check and quality control your house? Why not? There's one very good reason why you should not let your contractor do it. Yep.
CYA.
CYA. Sorry?
Cover your ass.
Well, but I already said that your contractor is perfectly honest. So your contractor will find his own mistake and say, "Oh, I'm sorry, I made a mistake here. I'll fix it." Yep.
He might have overlooked it. He's honest, but he might not realize he did it. How's he going to catch it the second time?
Exactly that. That's exactly the point. Okay. If your contractor missed something in the process of building the house, putting things together, that means that piece of information is missing already, in that phase of building the house, right? So when you ask the same person to check, that piece of information is probably missing as well. So he would not even go to check that thing, not out of dishonesty, but just simply, okay, it just never occurred to me that I'm supposed to do this part here, because if it did occur to me, I would have done that when I was building the house. So that's why you never let programmers to check and test and QC the software. You always rely on somebody else to QC, to quality check, quality control the software. And that's that person is usually called a test engineer. And it seems like it should be pretty easy, right? I mean, testing a piece of software should be pretty easy. And somebody is shaking his head. Does anyone want to comment on that? Go ahead.
I have a question more than a comment. So is a test engineer also a programmer?
It can be. Sometimes they have like two teams that are working on different projects. So team A can be can test team B's product and vice versa. Okay. So is testing software an easy task? Well, let me ask you a question. If I just write an algorithm, not like a word processing software or a banking system that are that complicated, I'm just writing a program to sort cards, okay, numbers, okay? You give me a stack of numbers, I will sort it in the right order. How do you test a program like that? Go ahead.
See if it does it.
See if it does it. Okay, very good. That's a good starting point. I give this program one single card. It returns that one single card. Hey, that's good, okay? Yes?
You need to do things that are unexpected to see if you can break it.
Aha. But in the case of sorting a stack of cards, the only thing that is unexpected is you can have two numbers that are the same in the stack. Okay, so you can give it you can give it like 3 cards, 1, 2, 2, or 2, 1, 2, and then see if it is sorting that correctly. Go ahead. You had a point.
I used to program PLCs.
Okay, programmable logic controllers.
Yeah. And we used to basically we had to make it bulletproof.
Mm-hmm.
And what we do is we program it, then we have to build a panel to hold it all, and then we get the dumbest guy we can find and tell him, okay, we want you to run this machine, and this is how you run the machine. And when this thing gets here, you push this. And guys, they knock eyes out of the way, and they, and then they call, hey, this is not working. And you go back there, and well, you're not supposed to do this.
Uh-huh.
No matter what happens, there's always some idiot that finds a way to break it.
Because they're doing something that the program is not designed to handle.
Yeah, and then you have to
Yep.
go back in the program. And then
Right. I hope you were not working for a nuclear plant back then. Yep.
You cannot give him every test case.
Exactly. There's no way to give the program every single possible test case. Okay. Now, if you think about sorting, okay, which is a very simple thing to do, right? You give the program one thing and say sort it. It gives you exactly the same thing back. It's good. You give it 2 things. Now, if you have 2 things, then you have 2 test cases, potentially 3 test cases already. let's say just 1, 2, okay, the 2 cards. So you can say, oh, the original stack can be 1, 2, can be 2, 1. But you can also try to trick the program and give it 2 1s instead. So there are 3 cases already with only 2 cards. With 3 cards, you have 1, 2, 3, 3, 2, 1, 2, 3, 1, 1, 3, 2, and so on. That's 3 factorial. And then plus, if you want to test the same numbers, then you have 1, 2, 2, 2, 1, 2, 2, 2, 1, and so on. There are 3 combinations with 1 duplicate. So when you add up to, okay, let's say you test the program this way, you work out all the possible cases, and you tested the program up to, say, 10 cards. What makes you think that it will work correctly for 11 cards? There's no reason that you should believe the program will work for 11 cards. Okay? Probably it will, but there's no guarantee. So that's why testing programs is actually very difficult. Okay? Now, if you think about a banking system, it's even more complicated, right? Because now it depends on which customer you're talking about. Maybe corporate customers would have a different set of rules compared to regular customers. Okay? So the number of possible cases to test the system is just huge, tremendous, and it's really hard to test every single case of a program to make sure the program works correctly in every single case. So that's why testing is not easy. Okay, there's no way we can say that this part is easy. In this class, we'll talk about program verification, which basically means we try to use mathematics to prove that the program is correct once and for all. Okay, and some people would like that part because some people like math, and other people will look at that and go like, whoa, this is way too much math. So when we get to that part, we'll talk about it. But do not underestimate the difficulty of testing. Yep.
Do they ever write programs to test other programs? Try to use every single possibility? Or is that just
Yes, they do. Yes, they do. They generate test cases to test other programs. Yep. And some programs actually have a back end. So even if the program is supposed to be interacting with a human, they have a back end so that you can have a program to interact with the program being tested to see whether it works correctly. Go ahead.
So system analysts?
Sorry?
System analysts? Is this a type of system analyst? Or
A test engineer is not a systems analyst, but they work from the same document. The blueprint is the most important document, because how does anyone know how to test a program? You start with a blueprint, because the blueprint will say this program is supposed to take input like these, and with these input it's supposed to give you output like that. The programmers will work out exactly how to make it work. The test engineers they don't care how it works. You can have little genies inside the machine and that actually does all the work. But the test engineers just look at the input and the output and make sure they match the blueprint of what the system is supposed to do. Yep.
Would the testing engineer be responsible for input validation?
If that is part of the specification of the software, yes, they would also have to do that.
I thought that'd be mostly the developer's aspects, because he's dealing with mostly the program development.
No, each person that we have mentioned actually has one piece of that one thing that you just mentioned,
Yes.
Input validation, which is like if you want to input zip code, it has to be exactly 5 digits, or 5 digits, a dash, and then followed by 4 digits, okay? So that actually has, each person along this line has some responsibility. First of all, the systems analyst has to say very specifically and say that when the client or when the user inputs a zip code, we need to validate it, okay? And the validation also needs to state, okay, what type of zip code are we talking about? Are we only limiting to 5 digits, or are we accepting both 5 plus 4, or are we accepting only 5 plus 4 and not just 5 digits? So that is part of the system specification and say, okay, this is the expected behavior of the program. The system analysts don't care how it is done. It's just that it has to be done. The programmer will now take the specification and say, okay, now how am I going to write the program to double check on these things? Am I going to use regular expression? Am I going to use string compare? Have my own function to do it? These are all little details. And then when it comes to the test engineers don't care how it is implemented, but they will have test cases to say, okay, let me input 1, 2, 3, 4, 5, 6, and see what happens. Oh, okay, the program rejected that, gives me a warning message that is appropriate. So that's why it is the job of all three parties to get it done correctly. Okay, very good. So now we can move on and talk about algorithms. Basically, what is an algorithm? When was the first time you were exposed or you heard of this term algorithm? Do you guys watch Star Trek, especially the Next Generation? No? Not a whole lot of Trekkies in this class. Huh? Well, they keep using algorithms in all the wrong contexts. So do not try to learn computer programming watching Star Trek. They combine terms and words that really have no relationship, and because it sounds cool in the show, they would use that term. Like data is Lieutenant Data is supposed to have a positronic brain, and then they'll start to talk about recursive genetic algorithm in his positronic brain. And all those terms are very cool, each one representing a very interesting aspect of computer science, but they don't combine. Okay? But what an algorithm is really just a method to complete a particular task, to sort a deck of cards. Okay, to find the largest number, given a bunch of numbers, to see if there are duplicates in a bunch of numbers. Okay, so those are, the methods to accomplish those things are called algorithms. Now, what makes an algorithm different from a general method is the following. First of all, an algorithm has to be very precise. In other words, when you read an algorithm, there can only be one way to interpret the instructions. Okay? Is that okay? When you read an algorithm, there can only be one way to interpret the actions. You cannot say, oh, I read this sentence here, I can do it this way, or I can do it this way. There should be no two ways of doing exactly the same thing for that instruction. Yep?
I have a question. Are we going to have like a quiz for these lectures, or?
Not this part. This part is really just an overview. Okay. So for the most part, I do not ask questions about these. I consider these topics, too soft for questions. In other words, it's really hard to be, absolutely right and absolutely wrong. But after this, when we start to get into the actual, programming language, then we'll have material that will be suitable for a quiz. But at this point, these are all pretty soft stuff. And an algorithm has to be very specific. In other words, you do not write an algorithm that can solve like 20 different problems all at the same time. There's no such thing as a multi-tool algorithm. Okay? One algorithm is one tool and is designed to handle one particular type of problem. It is also a good time to talk about classes that you may take at a university. If you're in a computer science track, not engineering, but in a computer science track, eventually you will encounter classes with the title of algorithm analysis or the analysis of algorithms, okay, one or the other. That's a very high level class. It's an upper division class at a UC or a CSU, and it's very math heavy, okay, it's heavy duty math classes. And in these classes, you will actually develop your skill to analyze an algorithm to 1, prove that it is correct. 2, figure out what is the time complexity. In other words, is it an efficient algorithm? Are there better algorithms to solve the same kind of problems? And so on and so forth. Okay, this class here, even though we have algorithm and design in it, is nothing like those classes. Those are upper division classes. Okay, now that we know what an algorithm is, how do we express an algorithm? Okay, the answer is, in this class, I only use pseudocode for that purpose. I do not use flowcharts. I do not use any other representation. I do use pictures initially so that people can correspond the textual representation of something with the graphical representation. So it makes it easier to understand what is a conditional statement, what is a loop, and so on. But after that initial phase, I do not refer to the pictures anymore. Okay? Now, why don't I use a graphical representation? Because these days everybody is moving in the direction of being graphical, right? I mean, everything we want GUIs. We don't want text stuff. We want everything to be pictorial. Well, one problem with a graphical representation is, if you want to make any changes to it, if you want to insert one more thing to do, it is much more difficult. Okay, you have to move a lot of stuff out of the way, and shuffle things in order to get one more thing done. It is also very inefficient from the input perspective. If you want to express adding two numbers, okay, yes, there are ways to make a completely graphical interface to write programs. It works really well and is really cool for the first 3 minutes. Once you have to write something that is more substantial, it becomes extremely tedious. Because by dragging and dropping the constructs, you have to waste a lot of time to go to the right toolbox, drag and drop the right thing, and then you specify the more details about that thing. On the other hand, if you use pseudocode or text to represent programs, you're just typing, and it's much faster that way when you're typing a program than dragging and dropping using a GUI interface. For those of you who are not convinced and say, I want everything graphical, I have one place for you to go. Not home, that's I wouldn't do that. I would direct you to the MIT website, and this is really a nice product. Okay, I use it sometimes in some of my other classes. It's called Scratch. What Scratch is a GUI type of programming environment where writing a program is truly dragging and dropping. Okay, you can write fairly big programs using drag and drop. And if you want to know, if you just want to know what it looks like, how it feels, you can go to YouTube and find MIT Scratch, and there are many video clips, many tutorials for this already. So you can just watch one of these clips and get a feel of what it is like to write a program using a completely drag and drop environment. Okay, and I think some of you will realize, hey, this is actually not very user friendly because it is very slow. Okay, every time you want to make some changes, you have to drag, drop, and do all kinds of stuff instead of just going to one line and make some changes on that line. But it's a good introduction, so you definitely go check it out if you have the time. It's optional, but I think it will give you a better idea of what it feels like when you have a graphical user interface just for programming. But in this class, we use pseudocode. What pseudocode means is it is not real. Okay, it's quasi, and code is program. In other words, the language that we use in this class is not suitable for a computer to understand. It is not very exact. The syntax is kind of wishy-washy, kind of flexible. So what good does it do? Why would I use pseudocode in a programming class when I already know that a computer cannot handle pseudocode? Yep.
It's easier to fill the gap between the English language and our code. It's a good medium that can allow somebody to relate in both areas.
Compared to machine code, definitely it is like that. But the pseudocode that we use in this class is not much simpler than actual programming languages. Okay, it is simpler, but not by much. I can give you a few reasons why pseudocode is useful. So we'll go ahead and talk about that here. First of all, it is precise. In other words, even though it is pseudocode and a computer cannot understand it, I still want to make sure that there are no two ways to interpret the same thing. So it has to be very precise. The next one is it is structured. Now, I can't really show you any pseudocode at this point because we haven't really talked about it. The only way, or I can give you an analogy to understand what is structured versus non-structured. Okay? How many people have a hard drive that is at least 500 gigabytes? Most people have terabyte hard drives these days, right? On a desktop computer or even notebook computers. What if I tell you that you cannot have folders? Everything on your drive, every single file has to go to C://, the root of the entire drive. I give you all, the 1, 2 terabytes that you want. It's just that the only requirement is there won't be any folders. Yep.
Will you allow index?
Index? Nope, just file names. Yep.
I'm going to develop a system of naming my files with first part as folder name.
Now think about that. That's not a bad start. But think about what you usually do with folders.
Really slow.
When you drag and drop folders, now you have to rename that bunch of files, and you have to find out what other files have the same prefix, and so on. Okay, that is structured versus unstructured. Okay, when we talk about a structured programming language, that means there's such a concept like a folder. One thing can contain another thing, and then a bigger thing can contain that, and so on. Okay, so structured will come in very handy. In fact, it is a very crucial property of pseudocode programming. Now, since you mentioned the PLC, now with PLC, it's all using schematics, right? Diagrams with relays, timers, and so on and so forth. So it is not structured. Or do you think it is structured?
It can be. They have some PLCs out there that there was 2 halves of the manufacturing place, and one PLC its only job was to talk to both halves of the.
Oh, okay.
Both halves of the.
So you can
process.
look at it as one box.
Yeah,
only.
and unfortunately, it decided to take a dump one night and
Uh-huh.
shut everything down for like 2 weeks, and they wanted $30,000 for the stupid.
30 grand is nothing. When you think about the downtime of a factory, 30 grand is drop in the bucket.
Yeah.
That's like half a minute,
Well,
30 seconds of delay.
But the thing was, they couldn't get it for 2 weeks.
Okay.
So,
so that's a lot of downtime.
You start pulling garbage out of this, out of the panel, and it's like, well, what do we do now? Well, you look at the program, and the program says that, okay, all these conditions have to be met before this valve opens up, right? Well, the conditions will never be met.
We'll talk about that in this class.
It's like you lie to it, and then you turn around and you had to wire it backwards.
Okay.
But each PLC that was attached to either side it had its own little box, and then it was inside another little box.
Okay. So there's a concept of a folder.
Yeah.
You can contain things and hide the details.
Yeah.
Okay, that's structured already. So thanks for the clarification. Because when I learned PLCs, it was only with ladder logic, and everything was discrete, and there's no such thing as structured.
Oh,
They changed that.
Quite a bit.
Uh-huh.
Now we have internal timers. We have stuff that that doesn't exist except inside the program, and it's a timer, and then it closes on a.
You can time out on certain things. Watchdog timeouts.
This other imaginary thing closes on this, and then it checks for this one over here, which is another imaginary thing before it says okay. Now we're going to open a valve, or now we're going to shut this thing off.
Now, for the rest of the class, who do not know the term what a PLC is, PLC stands for Programmable Logic Controller. They are little boxes that are placed in factories and power plants and whatnot, and their responsibility is to open up valves and close valves, control, conveyor belts, machines, motors, and stuff like that to automate, a plant, a factory, a power plant, and so on and so forth. Yep.
Also, make it quiet, because if you're using discrete components,
right,
like
a lot of clicking, right?
Motor controls, starters and stoppers, those things sit there and go bang, 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 and then you got a panel that's doing nothing but click, 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 click. And after about 30,000 clicks, fire comes out of it.
Yep, because the electrical contacts, do spark. Yep. Now, PLCs are interesting in a very in a way, even in terms of computer security, the PLCs are kind of interesting. How many people remember the name Stuxnet? S-T-U-X-N-E-T, I think. Okay, so what exactly is Stuxnet?
The way I understand it is a program that is supposed to attack PLCs and go right into machine code and keep replicating itself through a factory or a power plant or something, and pretty much just shut the entire thing down. It can hide for a long time. You can trigger remotely.
Yep, that's exactly what it is, and you can find a lot more details by just looking it up in Google. It's S-T-U-X-N-E-T, Stuxnet. For those of you who did not hear about this news and whatnot, I can just give you a brief summary. I think it was last year or earlier this year, the Iranians reported that their power plant was shut down by a computer quote-unquote virus. Now, when you think about a computer virus that Norton protects you from and stuff like that, a virus will turn your computer into a zombie. Basically someone else, a hacker, can remotely control your computer to either get personal information from your computer or have your computer to join a botnet in order to attack other computers, spread the virus, spam other computers, and so on and so forth. That's a typical payload or the typical behavior of a virus that targets consumers like us. Okay? Stuxnet as a virus does not do that. Okay? In fact, when it gets into your computer, it will just go there and go like, nope, this is not the kind of computer I want to infect, and it will just disappear by itself. What it does is it will get onto a computer that has the necessary software installed to control PLCs. Okay, so these computers will be the controller or the terminal of a factory automation system. Okay, and what it does is it does not just infect the PC that is overlooking or displaying or monitoring the whole process. The whole concept of PLCs is they are very distributed. In other words, as long as the boxes throughout the factory are still working, the monitoring PC, someone can take a big sledgehammer and just destroy it, and guess what? The operations goes on. You just lose the ability to monitor the process, but the process still goes on, nothing happens. So the Stuxnet virus does not just attack and attaches itself to the PC, it sends out the necessary instructions to reprogram all the PLCs distributed in the factory, or power plant in this case. Okay? It's very brand specific, it's very intent specific. And this one is intended to shut down nuclear plants. Okay? And the other part that is interesting about Stuxnet, you can read up on it too, is that it had 3 zero-day exploits. What is a zero-day exploit?
I don't know.
Okay, well that's okay. This is cisp300, so I'll explain it. Go ahead.
You're supposed to do 3 different things.
An exploit, in computer term or in computer security term, an exploit is a way to get into a computer, okay, to crack into a computer system. Okay, that's an exploit. A zero-day exploit means that this has never been discovered before, and therefore there's no fix, to fix it. It is really hard to get one zero-day exploit, okay? Because you can go to the Microsoft website and find out, all the exploits that they have found and fixed. That's easy, okay? All software publishers will release, patches and whatnot, and they'll describe this patch will fix all of these problems. It will close the security holes. So having one zero-day exploit means that somebody has to spend a lot of time to find out, how to crack or how to hack into a computer system and not getting detected. Having 3 was unheard of. So this is not the work of individual hackers. This is not the work of one little group of hackers. It's not the work of mafias. Okay. Okay. Are you guys getting the picture of the organization behind Stuxnet? It has to be a national level to pull enough resources to find 3 zero-day exploits and have the complexity to target specific controllers to shut down nuclear plants.
That
was the whole intent. Was supposedly Stuxnet virus was employed by the Israelis to knock out a couple Iranian nuclear power plants.
But not to cause a meltdown, because after all, they are kind of next door. Well, that's rumor, or people think that's the case. Nobody actually knew who wrote or who originated Stuxnet, but there were some strong suspicions. There were a few suspect countries, because the complexity that it needs rules out a whole bunch of countries automatically, and the specific target in this case also helps to focus on very few countries who would do something like that. And the other interesting part about Stuxnet was the Iranian power plant was actually disconnected from the network completely. It has no connection to the internet whatsoever. And I think they suspected it was infected by a USB thumb drive. So there was some human factor involved in order to sneak this into the plant. So read up on this one is really quite interesting, both from the technical perspective and also from the kind of political perspective. All right, so we'll talk about conciseness too. In other words, we want to use the least number of clicks and and key presses to express logic in this case. Pseudocode is language independent. Well, I wouldn't say it's completely language independent. In other words, I still use words like begin and end, which are derived from the English vocab. But other than that, other than maybe 10, 15 words or so, it has no resemblance of natural language, okay, of English. Now, in this case, it also has a flexible syntax, because the intention of pseudocode is not for a computer to understand; it's for another person to understand. So if you use, let's say, okay, most of the time we say this is 5 times j, right? But there's no such key as multiply on the keyboard. So in computer, we use the asterisk to represent multiplication. If someone, instead of using the asterisk symbol to mean multiplication, if someone gives me 5 multiply j, I would count that as correct as well. Because I'm a person, I can understand multiply is the same as the symbol, the multiplication symbol. So I would take either one as a correct solution. So that's what I meant when I said, I will accept a flexible syntax, because I don't need it to be too exact. Okay. And that basically is the soft part of this lecture. And now we are moving on. We have 10 more minutes. Is it 10 more minutes? Okay, we'll move on to the next topic. So we are actually going to start on variables, expressions, and sequences. So here's an example. The example is really old, because by today's standard, most people just do e-banking or e-bill and stuff like that. You don't need to do something like this. But in the good old days, when we receive bills by mail and there's no online banking, a lot of people have to do something like this. So what you do is you receive your credit card bill. Okay, so you open it up and you go like, whoa, it's that much. Who's spending money? And then after the shock factor, you have to figure out, okay, what do I do with it, right? So assuming that most people, assuming that person is going to pay off the bill, without owing the credit card company any money, this is something that person can do. First of all, you have to figure out what is the balance. Okay, the balance, I'll use X here to represent the balance. Now, why don't I just say, $219? Because it can change. Okay, it varies month to month, person to person, account to account. So that's our first exposure to the concept of a variable. Okay, X is a variable in this case, because I don't know what the amount is going to be. I can only use a symbol to represent the amount that we are dealing with. Okay, second step, we will go ahead and write a check of the same amount to the credit card company and return the payment. Okay, so the first two steps, should be sufficient. But most people would go, and also complete the last two steps. So here we will deduct this much money from our available funds. So let's say I have a checking account with Wells Fargo. So what I would do is I would go to my checkbook, I would write down the entry, and I would deduct this amount from what I think is available at the bank. Now, for most of you, this is absurd because you can just use a smartphone. In 2 clicks, you know exactly how much money you have in the bank. But remember, this is back then, when we don't have the internet available for online banking. So the only way you can know how much money you have in your bank instantly is, one, is to call the bank, but two, you can keep track of that amount as well yourselves. So we'll keep track of all that stuff ourselves using our checkbook. And if you want to, figure out how much money you spent through a particular credit card, you can also add a number to another logbook or journal that you keep, so that you can keep track of how much money you spent through each credit card. Because you might have a gas card only for gasoline. At the end of the year, you can quickly figure out how much money you spent on fuel and stuff like that. So are these 4 steps understood? The basic idea of that? Okay. So we'll use this example to talk about variables. A variable, as the name implies, is an object that can hold a value, and the value can change over time, and therefore the name variable. More formally, a variable has the following attributes. One is the name. In other words, I don't want to say that amount, this amount, the amount that I just mentioned in the previous paragraph. I want it to be very precise. Okay, so when I say x, it refers to a particular variable. There's no confusion possible whatsoever when I say variable x. The second one is a type. Now let's not really talk about a type at this point because it's a little bit early to talk about the type of a variable. But the variable also has a value. It is basically the state of the variable. In this case is how much do I owe American Express. Okay, that's the value. So in this case, in our example, how many variables do we have? The first one is x. I just explained that one when we looked at the previous slide. But we have other variables as well. In other words, if I want to keep track of how much money is in my checking account, that itself is also a variable. Because as I get my paycheck, that amount goes up. As I pay my bills, the amount goes down. So it does change over time, and as a result, it is a variable. Available funds is a variable. And the other one is AE total expense. Let's just say that I want to track my American Express credit card expenses. So that's also a variable because every time at the end of each month, that amount will go up. At the beginning of the year, if this is annual, then I have to reset that amount at the beginning of a year. And now we're going to move on and talk a little bit about this. We are running out of time in about 2 minutes. So instead of starting this topic, let me just give you this part here. Oh, that's not what I want. I want my editor. Pick one. Oh, that's fine. Okay, so I'm just using this, as a little whiteboard thing. What does that mean? There are 2 meanings. If you ask your math professor, it is expressing a relationship between the 2 expressions. It's a statement and say the variable x is the same as y plus z. It is expressing a relationship. In programming, we have something that will look like this. I challenge you, the next time you take a math class, maybe in the next period, ask your math professor, what does that mean? The response from the math professor is going to be, yes, he or she will probably just laugh and then just go like, that's not a very smart question to ask in a math class. Why? Can you find a number x such that the value x is the same as itself plus 1?
Infinity.
Well, infinity is not a number.
Well,
You can approach, you can take the limit to infinity, but infinity itself is not a number. There's no such thing, right? There's no such number where its own value is the same as the value plus 1. And yet, in this class, you will see this sort of thing all the time, because it is not expressing an equality between the left-hand side and the right-hand side. When we do things in this class, we are actually saying something more like this. We are saying this is a two-step operation. Take the current value of x, add 1 to it. That becomes the right-hand side. What are we going to do to the right with the right-hand side? We change the left-hand side with that value. In other words, what we are doing here is incrementing the value of x. If x was 3 before, it becomes 4 after this step. If x was 200 before this step, it becomes 201 after this step. So in programming, we see x equals x plus 1 all the time, and it makes perfect sense. But yet in mathematics, you look at x equals x plus 1, and it does not make any sense. So that's why, in this class, I just want to finish this part here. I don't use the equality symbol to mean assignment, okay? To change the variable, you have to use an assignment statement. I don't use the equality symbol here to avoid that confusion. Instead, I use a left arrow, because when I use a left arrow, it shows you implicitly what is the order of operation. You evaluate the right-hand side, and then you update the left-hand side. Okay? Now we are off for a weekend right now, so that I will see you guys on Tuesday. So read ahead of me, okay? Read ahead of me, finish at least how much we have talked about so far, and finish this entire module on your own, and then on Tuesday we'll talk about it.